All right, well, today we are moving ahead. We are jumping from section 5.3 into section 5.4, where we are going to be talking about the division of polynomials. The division of polynomials. Now, I know what you're thinking. You're probably thinking, really? This is going to be pretty challenging. Some of it is, I think, when we talk about division, most of what we're doing in this particular section is really going to be a lot of stuff that you've learned just growing up doing the traditional or normal division method, where we call it long division. But before we get into that, what I want to do is just go through these notes, and then we'll go through a bunch of examples, okay? So the first part of this lesson is really talking about dividing a polynomial by a monomial. What we're going to do is, in an example, say for example this guy right here, which is 8x cubed minus 4x squared plus 6x divided by 2x, what we're going to do is, again, because this is a monomial in the denominator, we divide each piece in the numerator by that very thing, and then we sum them all together. So we have 8x cubed divided by 2x minus 4x squared divided by 2x plus 6x divided by 2x. And then what you do is the rules of exponents that we talked about earlier in section 5.1, and we just divide the coefficients. So we do 8 divided by 2, that's going to be our 4 right there. X to the third divided by x is the same thing as x squared, okay, because we have 3 minus 1 in the exponents. Minus 4 over 2 is going to be a minus 2, and then we have a 6 over 2, which is equal to a 3. Again, over here, there's a single x that comes along for the ride. So this is essentially the basis for dividing polynomials. We divide each individual piece divided by that particular monomial, okay? Now, for more complicated polynomials, what we do is something called long division. And it's hopefully something that you learned in elementary school using just normal numbers, right? If you've got, say, 42 divided by 6, what you would do is to see if 6 goes into 4, it doesn't, then you move it over one's place. Does 6 go into 42? Sure enough, it does. It's 7, okay? In a same kind of sense, what we're doing is going to be dividing. And again, I don't want to spend too much time on this particular example because I just really want to walk through them. The big thing that I do want to point out is that if you are dividing this by this, the way that you set it up looks exactly like how you did it in elementary school. So the numerator is the thing that's underneath the division sign. The x minus 2 is going to be on the outside, and then again, I'll work through all the examples. When you get down to the bottom and you get a remainder, what happens is that remainder as a solution is going to be divided by what you initially started with. So if I were to simplify this whole thing up here, this very top thing, by working it out, doing this whole division, what happens is I'm left with x plus 4, which is what I divide, my solution that I got, so it's right there. Then what you get is the remainder divided by the thing that you were originally dividing by, okay? Now the goal is to get a remainder of 0 so you don't have this piece here at the end, but if you don't get a 0, then what happens is you just divide by what you started with, okay? Another example of a type of division that we can do using this exact same example, okay? A much more easy way to do it is something called synthetic division. It's a simple method that what we do is we look, and first off, when you do synthetic division, you have to make sure that the thing that you're dividing by, or the thing that you're dividing into, I should say, is divided by this. So it has to be of the form x minus a. In other words, it can be x plus 3, x minus 7, x plus 25, x minus 82. It can be anything, and as long as that's an x and you're adding and subtracting a number. It can't be x squared, it can't be x cubed, it has to straight up be x with another number connected to it, okay? So x minus a, what we do is we actually match it up with whatever is in the denominator. So if we have x minus a and we have x minus 2 here, that means that a is going to equal 2. So here's how you set it up. You create this little box thing, okay, and then the coefficients of the top, or the numerator, go right there. So we've got 1, 2, and 3. Okay, the constant term is the one that goes at the end. So you can see 1, 2, 3. The 2 that we found for our a value goes on the outside. And then what we do is, starting on the left-hand side here, again, I'm going to go through this example, so hopefully you can see. We drop the 1, multiply by the 2. So we get 2. That becomes this value. Add these numbers together. 2 plus 2 is equal to 4. Multiply by the 2. That gives us 8, which goes right there. 8 plus 3 is equal to 11. And then we're done. Okay? When you get to the last row, this is going to be your remainder. So the numbers that you get here, the 1, the 4, and the 11, they match up with the coefficients of whatever it is that you found. So x plus 4 plus 11 divided by x minus 2, which is exactly what we got up here. Okay? Right up here. Again, I'm going to go through a few examples, so hopefully you can see what I am looking at or talking about. So let's go ahead and jump over to our whiteboard. Give me a second here. I got to find it. Okay. So let's go through some problems. I'm going to do just a couple of the monomial ones that we saw at the very, very top. Here we've got 8x minus 12y divided by 2. So again, this is technically a monomial because it is a constant. And so what we do is 8x divided by 2 minus 12y divided by 2. Okay, so we split from the denominator separately. Now I want to point something out. This is not the same thing. Okay? You cannot do this. You cannot do that. That is not the same thing as this. Okay? You can only do it when you have a monomial in the denominator. Okay? A single term in the denominator divides each individual piece in the numerator, not the reverse. That is super, super, super important. Okay? It's crucial that you know that. So 8 divided by 2 is going to be 4, and we're left with an x. 12 divided by 2 here is going to be 6, and we're left with a y. Okay? So that is going to be our solution for number 10. Let's go ahead and do number 14. 10a cubed minus 20a squared plus 15a all over 5a. Okay? So here we've got, again, 10a cubed divided by 5a minus 20a squared divided by 5a plus 15a divided by 5a. Okay? So again, single term, we divide by each piece. And as a result, what we find is that we get, first let's just do the coefficients. So 10 divided by 5 is going to be 2. A cubed minus, so a to the 3 minus 1, because this is in the denominator, right, is going to mean we get a squared. 20 divided by 5 is 4. A squared divided by a is going to be just a. And then over here, we get 15 over 5 is equal to 3. a divided by a is just going to be 1, so we leave it like that. So that's how you go about doing these problems right there. Okay, let's do one more. Question number 18. 12x to the fourth minus 9x cubed plus 8x squared all over 6x squared. So here, again, it's the same idea. We're going to just write it out, 12x to the fourth all over 6x squared minus 9x to the third over 6x squared plus 8x squared all over 6x squared. Okay. This is equal to, let's do the coefficients. 12 divided by 6 is equal to 2. In other words, 6 goes into 12 2 times. It's another way to think about it right here. And then we also have x to the fourth divided by x squared. So 4 minus 2 is going to be x squared. Okay? Minus 9 over 6. Now this is a tricky one because technically you can't divide 6 into 9. Yes, there's nothing that'll multiply by 6 to give us 9. So the thing is, though, we can actually reduce this fraction down. Both of these pieces are divisible by 3. So if we pull a 3 out of each of these, they'll cancel. So 3 times what is equal to 9? Well, that would be 3. 3 times what is equal to 6? This is again, I'm kind of doing this, doing some mental processing for you so you can see how I think about this stuff. So I can pull a 3 out of both. They'll cancel with each other, and I'm wondering what times that 3 will give us 9, what times that 3 will give us 6. Now we do x to the third divided by x squared. 3 minus 2 is 1, so that's just going to be an x. 8 divided by 6, now this is the same idea. It doesn't look like, so I'm going through the numbers. 4 doesn't go into 8 or 6. It looks like it's 2. Okay, so now I'm going to pull a 2 out. 2 times what is equal to 8? That would be 4. 2 times what is equal to 6? That would be 3. Okay, so again, that's just another quick way of thinking about these fractions. X squared over x squared, those will cancel, and I'm just going to be left with my 4 over 3. Okay. So again, that's kind of just the nitty-gritty of doing division by monomials. Now let's jump into doing division by polynomials, okay, or a binomial in this case. The next couple are going to be just binomials. All right, so question number 26. Let's do x squared minus 14x plus 24 divided by x minus 2. Okay? So what we'll do is we'll do the setup where we have our x minus 2, and this is asking us to do long division. So here's my my division, minus 14x plus 24. Okay, you may need to slow down in this part. You may need to take some time, come back and rewatch it if you need to. Okay, I'm going to try to explain this as very best as I can. Okay, now a lot of times what happens is people get really kind of thrown off by this. So they see this and they see this and they're like, what the heck do I do? How do I do this? What you're doing is you're just looking at the x, okay? And you're trying to figure out what times this will give me x squared. In other words, x squared divided by x is going to be what? Well, that would just be x, okay? Now, here's what you do. X times x is x squared. Minus 2 times that same thing that we just found. So minus 2 times x is a minus 2x. Now, here is where a lot of people get confused. You're subtracting that stuff. So, here, because I'm subtracting it, these things are going to go away. The x squareds are going to go away. This minus 2x actually turns into a positive. Okay, so if you want, you can change this. So get rid of your brackets, and you can change this to a plus. Okay, you can do that if you want to. I kind of just like having the brackets, and then that way it kind of reminds me. So I'm going to keep this like this. Again, it's up to you. If you want to do it like that, you'll have to use an eraser on a pencil and not a pen. I prefer, again, this is part of the reason why I like doing it like this, is because I prefer using a pen when I do my math. I don't like using a pencil. It's just weird personal preference I have. But okay, so in any case, what we're going to do is now we're adding 2x to 14x, to minus 14. So minus 14 plus 2. Even though it says minus, remember it's a minus, so it's plus. Minus 14x plus 2 is going to be a minus 12x. Okay? Then we bring the 24 down. So this 24 comes down. Now, I do the exact same thing. What times 12 will give me, or sorry, what times x will give me a minus 12x. Okay? And the answer is just minus 12. So minus 12 times x is a minus 12x. Minus 12 times a minus 2 is a plus 24. And now remember, I'm subtracting everything. Okay? So now this becomes 0 and 0. How about that? When I get to the bottom and have a 0 remainder, that means that I'm done. So in reality, this is it. Okay? Even if you get a numerical remainder, you're actually going to be done. And the way that you know that is, by the way, the way that you know that you're finished, if you look at this, I guess the technical way to say it, I'll explain it here in just a minute, but the technical way to say it is, this right here will be 1 degree less than this right here. When I say degree, what I mean is that it has an exponent that's 1 less than what's up here. So you can think about this as like x to the 0, right? Or 0 times x to the 0, I guess, if you want to think of it like that. This has an x, this does not have an x. That means that I'm finished. Okay? So this is equal to x minus 12. Okay? So that's that problem. Let's go ahead and do another one. Here's another way to think. I should mention this. When you have this as a result, another way of thinking about this, the way it works out, is that x squared minus 14x plus 24 is equal to x minus 12 times x minus 2. Okay? These two things are equivalent expressions. So that is, and again, another way of doing it. In fact, you can think of it as almost like, well, yeah, I mean, that's basically another way of representing it or writing it out. So that was 26. Let's do question 34. X to the 3 minus 2x squared minus 3x minus 20 divided by x minus 4. Okay, now you'll see this has actually got 1, 2, 3, 4 terms up in the numerator. Okay? And again, after this one, I'm going to show you how to do synthetic division, because synthetic division is really cool, and it's a super fast way of doing these problems. But the long division way, there are just instances where you just have to do it. You can't use synthetic division. minus 2x squared. And remember, you can only use synthetic division when you have something that actually is of this form. So that works. If I have an x squared or x cubed or something in the denominator, it's just not going to work. Okay, so here we go. Here's what we're going to do. We look at the first thing, x, and we're asking ourselves what times x will equal x cubed. Well, the answer is just going to be x squared. And normally when I put these above, I usually put them above where their position is. So here there's an x squared, so I'm going to put the x squared above it. Again, it's just habit. So x squared times x is x cubed. X squared times a minus 4 is a minus 4x squared. And then you can bring minus 3x down if you want. Well, no, let's not do that. Not right there. Sorry. Remember, we're subtracting all of it. So remember, this becomes a positive. This 4x squared becomes a positive. So I've got minus 2x squared plus 4x squared is equal to positive 2x squared. And then I'll bring the minus 3x down. Okay. You don't need to bring the 20 down, but I'll just do it because why not? Now we do the next part. How many times does x go into 2x squared? Or what times x will equal 2x squared? It's going to be a 2 for a coefficient and then an x. Okay? So I get 2x squared. 2x times a minus 4 is a minus 8x. And then I divide. Or I'm sorry, I subtract. And remember, so these guys are going to cancel, the first terms. The second one, this becomes positive, so this means that I'm going to get a 5x, and now the 20 comes down again. Okay? Now I do the last, this is the last iteration. X times what will give me 5x? That would be a 5. So I get 5x. 5 times a minus 4 is a minus 20. And notice when I subtract, I'm going to get a 0. Sorry, I'm at the very bottom. You probably can't see that. That all adds out to be 0. And then we're done. So again, this solution is going to be x squared plus 2x plus 5. Okay? All right, that's that problem. Now we jump on to synthetic division. Question number 60. Okay? So remember, everything that we look at in the denominator has to be of the form x minus a. So this question, 3x, hang on. We'll do something with the cubic term here in a minute. 3x squared plus 19x plus 20 divided by x plus 5. Okay? So this matches the criteria for x minus a. So x minus a implies that a, in this case, is going to be, notice it's a minus. So if it's a positive coefficient right there, it's going to ultimately mean that a is negative. If it's negative, then a is positive. It's backwards. Okay? X minus a implies that in this case, a is equal to a minus 5. So here's what we do. We're going to write out the a value that we started with, or that we found, and then we're going to write kind of a rectangular looking box, and we do the coefficients in the top row. So this is going to be 3, 19, make sure you got enough space between them, and 20. Excuse me. Now, when you get to this point, the very first thing that you're going to do is that first coefficient, you're just going to drop it all the way to the bottom, okay? So that 3 is just going to drop straight down. Now what I do is I multiply that 3 times that minus 5. So that's going to give me minus 15, okay? So that number goes below the second piece. Now I do 19 minus 15, and I get a positive 4. When I do that, I get 4 times a minus 5 is a minus 20. So I do, again, the same thing. Minus 20 plus 20 is going to be 0, and that is going to be the end. So in other words, this equation up here in rational form is going to be, the solution is going to be 3x plus 4. Now the variable, let me just point out, the variable that you start with is going to be one less, it's going to have one less exponent than the highest one up here. So because I started with a 2 as the highest exponent, my solution is going to start with an x to the first. Okay? So that is how you go about doing that problem. It's weird. It's almost like it's just very, very strange kind of process. There's a lot of reasons for why this works the way it does, and reasons that I'm frankly just not going to get into in this class. But it is pretty amazing, actually, how this all works out. Okay, let's do one last one. I'm going to actually show you one with a remainder because I don't think that we've actually done one yet with a remainder. Question 70. So this is 5 minus 5x plus 4x squared plus x to the third, all over x minus 3. Now, the one thing you probably have realized by this point is that math is incredibly specific. Okay? You have to be very specific when you work on problems. Here, what you need to do is you need to make sure when you do synthetic division that you are putting it in the correct order. In other words, you start with the exponent that's the highest, and you work your way down towards the constant. So I am going to rewrite this into something that is in the correct order, okay? And again, you have to do this when you use synthetic division because you're using the coefficients from each piece of this equation. Okay? So now I have x minus a. That implies that a is going to equal, in this case, it's going to be a positive 3. Remember, it's the opposite of whatever sign is here in your binomial. So now we put the 3 outside. We'll do the box again. And we're going to use the coefficients from this, this top piece. So it's going to be 1, 4, minus 5, positive 5. Okay? The first thing we do is we drop the 1 straight down. Then we multiply by the 3. 1 times 3 is equal to 3. Then we add these together. Camera just turned off. Give me 1 second. All right. We add these together, so this becomes 7. 7 times 3 is going to be 21. 21 plus a minus 5 is going to be a positive 16. Okay? 16 times 3 is going to be 48. 48 plus 5 is going to be 53. This is going to be our remainder. The very last row that you get, or the very last column, is going to be the remainder. Okay, whatever you add it up to. If it's 0, great. If it's not, then tough luck. That's what you get. All right, so I'm going to have to erase this because I'm running out of room. So let me just write the coefficients over here. 1, 7, 16, and 53 is my remainder. Okay. So there it is. So that means that if these are my coefficients, that's my remainder. What's going to happen is, again, I look at 1 less than this highest exponent, so it's going to be squared. So I have 1x squared plus 7x plus 16 plus the remainder means that I take that number, 53, and I divide it by what I was originally dividing by. Okay? So this right here is our final answer. This is an equivalent expression to that guy right there. All right, I think that's all I have for this lesson. If you have any questions, again, don't hesitate to let me know. But aside from that, that is all we have. Have a good one.